Hey there and welcome back. We're about to dig into one of the simplest yet most powerful tools for thinking clearly, the flowchart. Seriously, it's all about taking a messy, complicated process, or just a tangle of logic in your head, and turning it into a picture that just clicks. It makes sense. So let's get right to it and figure out how to turn logic into a picture. But let me ask you something first. How do you draw a decision? I mean, really, think about that. Or how do you draw a process? Or the way information moves from one place to another? It sounds kind of abstract, doesn't it? Well, that's the exact problem that flowcharts were designed to solve. They give us a visual language to actually map out our thinking.
So you can solve a problem in a couple of ways. On the one hand, you've got an algorithm, right? It's just a list of text steps, like what you see on the left. It gives you the instructions. But a flowchart, that gives you the story. It turns that boring list into a map. You're not just seeing the steps anymore. You're seeing how they connect, where the whole journey is going, and you can grasp the entire solution, in just one look.
All right, so let's make sure we're all on the same page with the terms. An algorithm, well, it's basically the recipe. It's just a step-by-step procedure written in plain English that tells you exactly how to solve a problem. No confusion, no ambiguity. You can think of it as the blueprint, but in text form.
A flowchart, on the other hand, takes that text blueprint and turns it into an actual diagram. It's a visual thing that shows you precisely how the control, the action, flows from one step to the next. It's literally logic that you can see with your own eyes.
Okay, so to read this visual language, we've got to learn its alphabet, which is basically the shapes. Every single symbol has a very specific standard meaning. And that's what makes flowcharts so incredibly useful to everyone, everywhere. It doesn't matter if you're drawing out a super complex computer program or just a simple plan for your business.
Let's start with the essentials. I mean, every single process, no matter what it is, has to have three things: a beginning, an end, and, well, all the stuff that happens in between. And flowcharts give us a special shape for each of those.
And here they are. First up is the Terminator, that flattened oval shape. Think of it like a bookend. You're only ever going to see it twice, once at the very start and once at the stop. Simple. Then you've got the rectangle. This guy is the workhorse of the whole operation. Any calculation, any action, any doing part of your process, it all goes inside a rectangle.
Okay, great. But a process can't just exist on its own, in a vacuum. It needs information to come in, and it needs to spit out a result. So the question is, how do we show that data moving into and out of our little system?
For that, we've got the parallelogram. I want you to think of this shape as the doorway for all your data. If information is coming in, that's an input. It goes through the parallelogram. If a result is going out, an output, it also goes through the parallelogram. And those arrows? Well, they're just the roads connecting everything, showing us exactly which way the process is flowing. All right, now for what I think is the most powerful symbol in the entire flowchart language. Up until now, everything we've talked about has been a straight line, right? Step 1, then step 2, then step 3. But the real world isn't like that. Real-world logic has choices, it has branches, it has different paths you can take. And this is where the real magic happens. And here it is, the diamond. This shape is the absolute heart of any complex logic. Why? Because it's the only one that asks a question. It has one path coming in, but it can have multiple paths going out, one for every possible answer. This is how you draw a decision. Of course, when you start dealing with really big, messy systems, you're probably going to need a few extra tools in your toolbox just to keep things from getting chaotic. So let's take a quick peek at a few of those. Really, you should just think of these as awesome organizing tools. That module shape, it lets you bundle up an entire separate process and just stick it in one box. Super clean. The hexagon is a handy shortcut for any kind of repetitive loop. And connectors, oh man, these are lifesavers for huge charts. They're like little portals that link one part of your page to another, so you don't have this crazy spider web of lines everywhere. Okay, that's enough theory for now. Let's actually see these shapes in action. We're going to build a flowchart together, step by step, to solve a real problem. And we'll start with a nice, simple, straight line calculation. Here we go. First, we put down our start terminator. That's step 1. Then, we need our inputs, so we use a parallelogram to read the principal, rate, and years. Got it? Good. Next, it's time to do the math. That happens inside a process rectangle, where we calculate the simple interest. Once we have the answer, we need to show it, so we use another parallelogram to print the result. And finally, we cap it all off with a stop terminator. See that? It's a perfect, logical, visual flow from top to bottom.
Okay, so that was pretty much a straight road, right? No turns, no choices. But what about a fork in the road? What happens when our process has to actually make a decision and do something different depending on the answer?
Let's tackle a classic problem that needs exactly that, figuring out if a number is even or odd. This one just can't be a straight line. It absolutely requires a choice.
So it starts off pretty normal. We have our start symbol, then we use a parallelogram to read the number. But then we hit the most important part, the decision diamond. And it asks a really simple question. When I divide this number by 2, is the remainder 0? And depending on that yes or no answer, our logic is about to split into 2 totally different directions.
And here are those 2 paths laid out for you. If the answer to the question is true, we follow the path that prints even. If the answer is false, we go down the other path and print odd. This is what we mean by branching logic. And of course, after we've printed one or the other, both of those paths would then come back together and lead to our final stop symbol.
So, okay, we know how to build them now, but the bigger question is, why should we? What's the actual real-world benefit of turning our logic into these diagrams? I mean, what's the payoff for everything from coding to just managing a project?
The advantages are just huge. First off, communication. It is so much easier to get your whole team on the same page when they're looking at a simple picture instead of a wall of text. Then there's finding mistakes or debugging. You can literally trace the lines with your finger and see exactly where the logic breaks. They also help you break a giant, scary problem down into smaller, manageable chunks. And maybe best of all, they're language independent. That means the same flowchart can be the blueprint for a program written in Python or Java or any language you want. This quote here really just sums it all up perfectly. A flowchart is that essential middle step. It's the bridge that takes you from the confusion of a hard problem to the clarity of a working program. It lets you sort out all the logic visually long before you have to worry about writing a single line of code.
So I want to leave you with this final thought. Flowcharts are not just for coders. Not at all. They are for clarifying any process. Planning a big project? Troubleshooting why your Wi-Fi isn't working. Even just mapping out your morning routine to be more efficient. So my question to you is, what messy process in your life right now could be made crystal clear with just a few simple shapes and arrows?